Morning, all of you. Today, our topic is law of conservation of momentum. This law of conservation of momentum states that when two bodies interact with each other, the sum total of their linear momenta is constant. What did I say? When two bodies, in this case A and B, interact with each other, the sum total of their linear momenta remains constant. That means the momentum remains conserved. Now let us understand this law with the help of a simple example. Let us consider two objects, A and B, having mass ma and m. Let us assume that the initial velocity of A is uA and initial velocity of object B is u. This figure is showing the status of the object before collision. Now let us assume that these two objects collided for time t-second. So during the collision, object A will exert force on object B and object B will exert force on object A. So, according to Newton's third law of motion, action and reaction are equal and opposite. So, that is why, see, during the collision, we are representing that these two objects have collided with one another for time t-second, and object A is exerting force on object B and object B is exerting force on object A. Then the third situation is that for time t seconds, the object separated, but the velocity, since they have collided with each other, the velocity of the objects has got affected. So let us assume that the final velocity of object A is equal to VA and the final velocity of object B is VB after collision. So these three situations, keep these three situations in mind. Then, as we know that momentum is the product of mass and velocity, so initial momentum of object A will be ma into ua, because u is the initial velocity and m is the mass of object A. Final momentum of object A will be product of mass and its final velocity, so we have written ma into va. Therefore, the change in momentum of A can be written as ma va minus ma ua. The change in momentum of object A will be the momentum of body A, final momentum of body A minus the initial momentum of body A. So that comes to be MAVA minus MAUA. So we have seen that the rate of change of momentum of body A will be equal to MAVA minus MAUA. And therefore, this rate of change of momentum is equal to FBA, that is force exerted by B on A, is equal to MAVA minus MAVA. This is the force which is exerted by B on A. Similarly, as we have taken out rate of change of body A, in the same way, we can take out the rate of change of momentum B, which will come to be equal to MB BB minus MB UB. That means the final momentum minus initial momentum of body B upon D, because we are taking out rate of change of momentum. So if we apply Newton's third law of motion, we know according to Newton's third law of motion, force applied by body A on B will be equal to the force applied by body B on A. So from there we can write down FAB is equal to minus FA minus FBA. Why? Why minus? Because according to Newton's third law of motion, the magnitude of force A applied on B will be same magnitude. With the same magnitude, B will apply force on A, but in opposite directions. So therefore, we have to use the sign minus. So hope you have understood this. So from here, we further derive that children, we have seen that action and reaction according to Newton's third law of motion are equal and opposite. So force applied by object B on A will be equal to force applied by object A on B, but they are in opposite direction. So we can write from third law of motion FAB, force applied by A on B, is equal to minus FBA, that is force in opposite direction, force applied by B on A. So from here, from this equation, if we substitute the force of A or the rate of momentum is rate of change of momentum is a force. So that is why we can replace it by the equation in this way. That rate of change of momentum of B will be mv Vb minus mv ub upon B is equal to rate of change of momentum of A. So MAVA minus MA. We have equated according to Newton's third law of motion by substituting the values of F. So when we get this equation, you will see that T is common in both the places. So we can take out T, common take out T. So what we will get? MVVB minus MVUB is equal to minus, because it is in opposite direction, so we will retain this minus sign, minus MAVA minus MAUA, rate of change of momentum of body A. So we can write this. If we solve this equation, we will get that. If you solve this minus sign, we will get this equal minus minus into MAVA will be minus MAVA. Minus into minus will be plus, so it has converted to plus, and it will be equal to MA. Okay, so if we bring the similar terms on one side, we will see that MVVB plus MAVA, we have brought the final momentum on one side. The final momentum of object B plus final momentum of object A will be equal to initial momentum of object B plus initial momentum of object A. By solving this, we will get this equation. Hence, it is proved that the law of conservation of momentum holds good. That when two objects interact with each other, their sum of total momentum of the two objects is conserved. Okay, thank you.